Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of it, you will have the opportunity to hear it again. Later on today, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll take probably about 10, 15 minutes near the end of today's presentation and go through as many audience questions as we can. And also at the end of today's webinar, we are going to be doing a giveaway for 3 Amazon gift cards worth $50 each. So stick around and hopefully you'll be one of our great big winners. And we also have a couple polling questions during today's webinar, so 4 in total. So please, hopefully we'll get you guys involved, and I'd love to hear your responses. So with that, we'll go ahead and kick off today's webinar, which is CICD pipelines for microservices, best practices. Our speaker today is Dan Garfield, who is the Chief Technology Evangelist at CodeFresh. And he is going to be joined by Kostas Kapolonis, who is developer advocate. Welcome, Dan and Kostas. Thanks so much for joining me today. Appreciate it.
Thank you. Great to be here. We're going to have Kostas joining us a little bit later for the Q&A section. He's a great member of the team and has a really strong, great background in DevOps. As you mentioned, my name is Dan Garfield. I'm the Chief Technology Evangelist for CodeFresh. You can find me on Twitter at @todaywasawesome. And my goal is usually just to get more Twitter followers. That's why I do everything. Just want to be more popular on Twitter, so I appreciate it. I'm a Google developer expert focused on cloud and Kubernetes, and I'm also a member of the Forbes Technology Council, where I mostly write about DevOps or microservices or things like that. So now that you know who I am, I think I want to just launch a poll as we start getting into the topic. I'm going to be asking if you're currently using microservices, and just interested to see what the lay of the land is in terms of our readers, our listeners here. And we'll end this in just a second. We're going to get into the discussion about microservices. We're going to, and as far as topics go, we're basically going to discuss, we'll spend maybe a minute on why microservices. I think most people at this point are pretty well convinced if they're convinced. Otherwise, they're not getting convinced. And then we'll get into some of the best practices and some case studies that we actually looked at and going through this. So I'm going to go ahead and close the poll now. Looks like most people have had a chance to vote, and looks like most people are using microservices. It's about half and half, with a lot of you using Kubernetes. So that's good. All right, so I've got a good sense of who the audience is. Let's jump into this. So first off, why microservices? Well, actually, I'm going to take a different approach to this because obviously it's been discussed in computer science many times, computer science terms, but I'm going to discuss it from the terms of a actual old school experience. This, for those that don't recognize it, is Apollo 11, or it's Apollo 13. Apollo 11 landed on the moon. Apollo 13 did not land on the moon because you can see that there's a big, giant gaping hole on the side of it. This was a mission that happened almost 60 years ago. It's about 55 years ago. And I think that this whole disaster and the recovery actually has some great lessons in microservices that were learned by NASA. Now, basically what you have here are essentially 2 monoliths. You've got monolith 1, which is the LEM, the lunar lander over here, and then you've got monolith 2, which is the command module. And the problem is that the command module that's supposed to take him to the moon, basically some of the oxygen tanks exploded and they lost power in it. So they had to shut down all the power. in monolith 2 over here, and they had to basically use monolith 1 as a life raft. So they did have two different services, but they're very monolithic in nature. Now, there's this great moment. If you haven't seen Apollo 13, you should super watch it. It's an awesome movie, where they realize that in the lunar module where they're staying, they don't have a way to get rid of the carbon dioxide that's accumulating from them breathing. And they have filters, they have tons of filters that they can use to get rid of this, but they're all designed for monolith 2, which is meant to be carrying them to the moon. And so there's this great moment in the movie where this engineer says, we need to make this fit into a hole made for this using only this. And this is an example where they had two different kinds of filters. This was not a microservice mentality. If you had a microservice mentality, then these things would be interchangeable, right? And you would have more reliability. So this is this is my sort of non-computer science explanation for why microservices are valuable, because we get to reuse components and have them be reliable. So there you go. Hopefully you found that fun. That's my brief explanation. So we're going to jump right into a case study here. This is one we looked at with Expedia. Expedia went through a move to microservices a few years ago. Basically, they had several monoliths. Basically, their cars, there were many of them, but the example we're going to look at is cars. They had several cars-related monoliths, and this would allow people to search for cars, to book cars. It would connect to their phone apps, and they basically had three different ones covering different areas, and they had an acquisition, so that had its own monolith, and they wanted to basically have a unified UI. They wanted to have single service for search. They wanted to have a service for sorting. They wanted to have a service for booking. So this is all making a lot of sense from just an architectural standpoint. So the question really became, from a DevOps perspective, how do we support all of these new microservices in a scalable way that's going to make sense? Because before we basically had 3 services, and now we're actually going to have quite a few more. So the approach that was taken in Expedia was basically to consolidate the code bases, and then for the CICD platform, they built shared libraries that they could reuse across lots of different pipelines. The goal being that they wanted to have reusable components. That felt sort of microservice-y, right? In fact, it's actually a monolithic approach, which we'll get into. And they still had to rely on manual integration testing. And they did try to standardize the CI/CD pipelines and use Maven for some modularity, but this approach actually left a lot to be desired. The consolidation that they wanted to do was actually too difficult, and they had to give up on it. The number of pipelines and the microservices exploded. They went from 100 pipelines for everything to over 1,000, which made it a lot more complex to manage. And it turns out that the pipelines weren't actually modular or reusable enough. And then they had a lot of issues with just copy and paste causing things. And they had a centralized team that was trying to manage all of it, and they couldn't keep up with this new explosion in services. So trying to move all this in was a pretty rocky road. And the last thing that happened, of course, when you use shared libraries is that as you upgrade those plugins, because they are shared, you end up breaking people's pipelines. It causes a lot of issues. We're going to get into it a little bit deeper as we get into the best practices here. And again, I will remind you, please feel free to post questions into the webinar here. Those are definitely really valuable. Looks like somebody was just asking if saying that they couldn't see. I think everybody else can see. So if that's a persistent issue, let me know. All right, so the lessons learned, one, they had this idea that they were really meeting the business needs, and they needed to actually standardize the CI/CD templates a bit more, and that this was actually going to allow them to get the business needs taken care of, even though it's not typically viewed as being critical to get done, the CI/CD components, but of course it is. If you're going to scale a project like this, it's the most critical component. We also found that the modular pipeline approach, the way they went about it using shared libraries was a miss. And so taking from that, we can actually use a more microservice oriented approach to our pipelines. And reusability and using one pipeline for multiple services, those are really critical to make it a lot easier to manage your pipelines in a scalable way. So that was really good from Expedia, the experience they went through. Now, to understand this shift, we're going to look at how pipelines are usually organized for monolithic applications. So usually you have a single pipeline for a project, and that pipeline can be complex or difficult to maintain, and it's not necessarily a problem. You don't necessarily mind, because if it breaks, you only have a couple of them, and so you can maintain those fairly easily. Whereas if you have 1,000 of them, obviously, if they're breaking all the time, then it's a problem. It's a bit like, if you have like a Formula One race car, does it matter that it breaks down every third lap? No, because you've got like a whole team of people to work on this one car. But if you're maintaining a fleet of vehicles, that's a big problem. You need to have a lot more reliability on that thing. And then the other issue with monolithic applications and the approach is usually that these pipelines are actually led by a single team. And this is actually counter to how DevOps is supposed to work, where you really want to put the power into the hands of the engineers and facilitate their productivity while balancing the needs of stability from the operations team. So this approach doesn't translate well to microservices because it doesn't scale well. And that's the big thing. It becomes a big mess to try to maintain. So this approach, I think we can safely say is a miss. Now, the other issue is with scalability is as you take, let's say 3 monolithic applications, you split those things into microservices, you're going to have an explosion in how many services you need to maintain. So if you take the approach and each of those services, each of those monoliths becomes 4 different microservices, all of a sudden you're looking at a dramatic increase in how many pipelines you need to maintain. And this is an issue. This is difficult. Doesn't look like much of a plan, does it? Now, the shared library component that Expedia tried, this is very common. We see that this is kind of a go-to for a lot of people. People think of it almost like microservices, but it's not, because these libraries are, they're actually a very monolithic approach. Essentially what they're trying to do is turn their CICD into a monolith. And that's a problem. So what the theory is, well, I have a task, a common task, like building a Docker image, let's say. And I'm going to build that into library A, and everybody can just use that. Well, the problem comes in almost immediately, because one team will want to use a different version to build with. And now you have the issue of, well, you can't use that version because we all use the same library. And so they push and they say, well, let's upgrade it. And then they upgrade the library. And of course, this breaks everybody else's pipelines, which weren't designed to use the newest version. So this conflict that happens because everybody's basically getting forced into the same versions, the same tools, the same software, it becomes an issue. And the kind of glue between these components becomes unstable, difficult to maintain. And it also requires a centralized team, right? So you basically have to have a centralized team listening to all the different stakeholders and saying, well, library A, we need to upgrade it, or we shouldn't upgrade it. I need to check with these other people. And so people will have a simple request like, oh, hey, we need to have access in this library to the AWS CLI. And now they've got to wait 4 days for the centralized team to look at it and decide if they want to do it or not. And if they do, then maybe it breaks other people's stuff. It's a very slow, inefficient way to work, and it doesn't really take advantage of microservices. So it's a bit of a miss. So this approach is a fail. Requires everybody to use the same version of library. That's a bummer. Libraries often rely on each other in complex ways. So maybe library B relies on something from library A, but these things aren't packages. It's not like a package manager where you say, hey, library B is needed, give me this version of this tool. It just says, it just is expecting the components from library A to be there. And so when you change library A, you may actually break library B. And again, this is not the way that, this is the way monoliths work. It's not the way that microservices are supposed to work. All the changes have to go through admins, right? So you have to get them involved, and this slows everything way down. And it leads to problems with stability. And the other issue is that this library model typically relies on a proprietary API. And when I say proprietary, I'm talking about, like, for example, if you're using Jenkins, you need to be using the specific Jenkins Groovy model of doing this. And so if you want to do something like maybe write some logic in Python or Go or something like that, that's actually really difficult to do because you have to basically use the Groovy API that's there. So let's start getting into the antidote. So now we've looked at kind of how to do this the wrong way and what's going to lead to some headaches. And I think people tend to respond to pitfalls a little bit better than they respond to best practices because we're all more likely to just fall into pitfalls. So these are the dangers of taking some of these approaches. These are some of the downsides. Now, I'm sure there are some companies that through great effort and with lots of discipline and dropping the hammer are able to make this work, but it's not a very efficient way to do this stuff. So I'm going to talk to you today about how CodeFresh is doing this. Now, we are CodeFresh, if you're not familiar, we are actually a CICD platform, but we are built on top of microservices. We're actually natively built on top of Kubernetes. Our application is made up of about two dozen microservices, and the approach that we take is one that we've seen work really well for our users as well. And so we're going to look at three different components. One is container-based pipelines. Two is shared pipelines, very different than shared libraries. And three is about deployment testing. We'll just spend a minute on that because it's relevant. So this is our architecture. You can see we've got a whole bunch of different microservices here. We've got an API gateway that handles it, but that's linking back to a whole bunch of microservices. We support a bunch of different runtime environments. We have tons of integrations. We've got our CLI and our webhook. We've got a bunch of different clients coming in. So this is actually a fairly complex architecture. Now the great thing about it is it's scalable, right? So we can, and this is important for us because we support people building either running their pipelines on our cloud or on their cloud, their private cloud. So we actually have clients that we need to maintain. And we need to be able to take somebody spinning up 10,000 pipelines and be able to scale our system. So this architecture allows us to do that and to scale all these services in an independent way, and also gives us the advantage of improving the maintainability of all these components because they're segmented out nicely. So the first thing that we really strongly recommend is container-based pipelines. This is very different than a shared library. What this means is that when you have a task, and let's say the task is to do a deployment to Kubernetes, you basically build all of the job that needs to be done into a single Docker image. And that image can be versioned. And this means that if I want to add in functionality, I can basically make a pull request onto the library maintaining that image. And if we upgrade it, it doesn't necessarily mean everybody else has to upgrade because they can select the version that they want to use. And if they want to use a newer version, they can grab it and use it. It also means that users can self-serve these things. So if somebody needed to fork it, they can. If they want to build their own images, they can. If they found something useful on Docker Hub, they can grab that and pull it in. And a big component of this is that the images do not rely on each other. So think of it like this: if you have like the Kubernetes deploy step, this might need if you're going to support EKS. Then you're going to need the AWS CLI to handle the authentication. But if you had a shared library model, you would have a single instance of the AWS CLI, and then you would have to maintain its version to coincide with the version of Kubernetes that you're using. Now, because other services might be using it. But I, with an image approach, don't need to do this because the image is packaging all of the components it needs to do all of its work in a single image. And none of it's relying on a separate package system or something like that that could get out of date or out of sync. And the other advantage of this is that these containers can be anything. So rather than writing it in Groovy, I could write a step in Node or Go or C++ or Java. And because they're in their own container, they can maintain their own versions. So unlike a shared library system where, let's say I'm using, I don't know, Java 2.4 or whatever. That means that everything basically has to use that same version of Java as its dependency. With container-based pipelines, I can have mix and match versions in the same pipeline because they actually aren't interacting with each other on the process level. They're only doing their job and moving on. So you can see how we do this with CodeFresh. You can see basically it's step 1, step 2, step 3, step 4. They're each their own container. And what we do to make it easy for people to create these kinds of pipelines is we create a single shared volume that all of these steps can read and write from. And so on step 1, container 1 spins up, and typically what you'll see is like the first step will be like a git clone, right? So that has that image, that step has everything it needs to do a git clone, and nothing more. Again, it could be used, it could be have different versions of different software on different steps. And it's not going to matter because it's isolated to that container. So I have my git clone step that's going to push the code down into the shared volume. And then my step 2 might be a build step. So let's say I'm building with Node. I pull in a Node image for the version that I want. And the code is right there, so I can actually execute my my build. Or with Node's case, I'm probably doing like an npm install. And the great thing about this volume is this volume is actually persistent. So that means that every time I run this pipeline, this volume has everything stored in it. So a nice side effect of this model is that I have caching built in, and I don't have to do any real work to configure it. It's just going to happen automatically. And a nice little bonus, this is kind of a sideline discussion, this volume is actually portable and distributed. So if I have 3 different clusters that I'm executing pipelines on, it will actually automatically handle that volume being distributed to those different clusters. And it'll also handle the security aspects. So if somebody like opens a pull request, that volume is not going to be exposed to that pull request because we wouldn't want to give them access to a volume that had production stuff on it. That's just a common security thing, but in a lot of these older systems, you have to manage the cache yourself, and it leads to issues where you end up having security vulnerabilities because you didn't think through all the implications of how that cache is exposed. Anyway, that's a bit of a sideline. So for these container-based steps, we do have a little bit of a gift for you, which is that we have a whole library of these that you can use at steps.codefresh.io. We have everything from approval steps to canary deployments to Kubernetes, to clone steps, to serverless deployment steps, testing suites, security suites, all those kinds of things. And of course, you can use your own. Now, these are all basically just Docker images that take arguments. So you can use any Docker image in a step. That's actually a freestyle step. That's how that works. And essentially, these are basically all like freestyle steps. They're basically just images, except that they have a schema associated with them, so they have set inputs and outputs. So feel free to go and pilfer that library of open source material. There's a whole bunch of great stuff in there. A lot of it contributed by the community. Some of it's maintained by CodeFresh, but these are things you can take and use today. So snag those. Now, the second thing that we're going to talk about. So if you do want more information about container-based pipelines, feel free to feel free to check out. We actually have another webinar that we previously did with DevOps.com called Container-Based Pipelines or Docker-Based Pipelines that goes really deep into just that topic and how to really hands-on use it. We covered it in a little bit quicker way, but feel free to go look that up afterwards. Maybe we'll add that into the email, so it's a good related topic. All right, so the second thing is to operate a single pipeline with multiple contexts. So here you can see I've got a pipeline. I realize you can't see my mouse. I'm moving my mouse over it. Just imagine me pointing at the screen and guess at what I'm pointing at. I've got a pipeline here that shows, it's got a number of steps, but you can see I have a whole bunch of different triggers. And so the idea is I have a single pipeline that multiple microservices can use because they're gonna operate off of the different triggers. And I'm gonna show all of this in a demo here in a second. But basically, this does require you to have a uniform approach for microservices, which is good. And you can reuse the same pipeline over and over again. And then you can actually change the behavior based on the context. So, for example, you can actually load in from these different repos things like which vault or which keys they're supposed to bring in with them, even though that it's not necessarily stored in the repo. And you can have it set different deployment environments. It's going to have maybe different Helm package names. It's going to have different Terraform files, whatever, and they can operate basically just based on the context. So the way this essentially works is in your code base, you have things like tests. They could be in a separate code base too. You could actually check out from 2 different code bases or 5. But you have your tests, maybe you have Docker Compose, maybe you have a Helm chart, maybe you have dependencies. And those things are essentially carried with trigger into the pipeline. And that's how they're going to operate. So let me show you how that looks. I'm going to switch over to CodeFresh here. So now I'm inside of CodeFresh. Make sure everybody can still see my screen. Yes, okay. So here I am inside of the CodeFresh CICD platform. You can see I have a whole bunch of different projects here. I'm actually going to jump straight over to a pipeline that I'm looking for. Now we've got a pipeline here called CI, and this is literally, we can see it has a success rate of 27%. That's actually great, by the way. If your pipelines are 100% successful, it usually means that you're not testing in a robust enough way, or maybe you just have perfect engineers. I don't know. That happens. So anyway, we've got this pipeline over here. Usually takes about 6 minutes to run. Not too bad. And if we look at, let's look at a build first, so we can see what this thing is actually doing. We can look at the syntax as well. And let's look at this guy. All right. So here you can see we've got a nicely staged out pipeline that's running. We've got a prepare stage, a test stage, and a build stage. And basically, it's going to clone the repo. It's going to grab some variables and load them in. It's going to validate the version. In this case, this one didn't create a pull request, but it could. It's going to install some test dependencies, and it's going to run some steps in parallel. It's going to do some code linting and run some API interface linting, running the unit tests, executing composition tests. Here we have a security scan step that, in this case, is giving us a red flag that's actually not stopping the pipeline, but basically a minor issue for us to look into. We generate test reporting, we attach that on here. So we actually be able to look at the test report here, and if we do, we're going to see, looks like we have about 3,000 test cases. We can actually look at the test suites that are used here. I suspect, yeah, so here are all the different test suites that have been run. If we look at the graphs, we can actually see, looks like, yeah, in this case, there were some tests that were skipped because they weren't relevant for this service, but pretty much everything else passed. So this is a good result. We're pretty happy with this one. Okay, so we've got this single pipeline. This is a CI pipeline, and if we go back and look at this, what I'm going to show you is that this pipeline is defined once in a code repo here. But if we look over here at the triggers, what you're going to see is that there are a ton of different triggers here. And these are triggers for all the different services that are using this one pipeline. Now, I don't know that every single pipeline, every single microservice all goes through this one CI pipeline. Certainly many of them do. But this allows us to have a common kind of interface for doing our pipelines. So this is a single pipeline that is maintained for many different microservices because those microservices are uniform. Again, this is different than that shared library model because we're using the container-based pipeline. So you can see here we have a git clone step, for example. And you can see it's actually locked, so only ever, even if there was somehow a trigger from a separate repo, it's only ever going to check out repos from our CodeFresh.io Git provider. Now this does work with multiple Git providers. It would just be a different Git would be flagged here. And you can set conditionals on these steps as well. And it's basically going to check out the repo and the current branch revision for whatever the trigger is. And if we look at one of these triggers, let's look at this guy. You can see this is basically just taking any push commits on the master branch. Now you do have a modified files expression that you can set. If you're using monorepo, you can basically say, hey, only if stuff in this subdirectory changes do I want this to run. You can also do the same thing with pull requests or pull request comments. So if you have a pull request, you can do like a /test to trigger these things. And then you can see it from there on in. It's basically a pretty standard pipeline. We've got a few conditionals, checks to make sure that the clone checked out. We load some variables. Now the way that you load the variables is basically they get written to the shared volume, and then they can be picked up later. So this is a fairly easy to read pipeline here. You can see we've got a parallel step that has several sub steps beneath it. One to do a code lint and one to check the API interface. So these are pretty straightforward. In this case, we're using Yarn. So this is a single pipeline, lots of different triggers. This allows us when somebody adds a new microservice, they can essentially just add a trigger and make sure they're following the template that's prescribed here. Now, this is optional, right? So if a developer has some compelling reason not to use the shared pipeline, they can certainly do that, create a new pipeline, create a new trigger, and they're off to the races. But already, just by taking this approach, we've eliminated the need for an extra 24 pipelines that we otherwise would have needed if we were taking a traditional approach to CICD. You can see we also have a shared pipeline for continuous delivery. So if we look at the CD pipeline, this is actually taking, again, a whole bunch of different triggers. In this case, what it's actually really looking for is new Helm packages. We are using Helm at CodeFresh. So what we did in our CI step is we basically packaged up Helm packages, and then we opened up a pull request into these different repos. And if we look at these triggers, you can see they've actually got this is using monorepo. So it's actually looking at a specific folder, a specific lock that has changed to trigger the deployment. And if we look at the deployments here, let's look at this one. You can see how this works. Basically, prefers some environment variables, clones the repo, copies those into a test environment. It actually runs a test environment here. In this case, it was skipped because it wasn't part of the test suite. Deploys to the SaaS environment, sets the requirement locks, and then post-deploy, it runs end-to-end tests, sends a Slack message, and any error reporting is sent out. In this case, there's no test report associated with this. So this is a standard CD pipeline that we use. We can actually look at the metrics over time of how much memory this is using. We can look at the timeline of what steps took the longest. So the deploy to SaaS step took the longest. And if we look at the YAML here, this is basically using our environment creator image that we use over and over again. And then we can actually track state and look at variables over time. Now, in this case, I do have all encrypted variables, so we should be safe here. So that's the idea of using essentially a single pipeline, or in this case, two pipelines with a lot of different triggers in order to have a single maintainable pipeline that's easy to maintain, that follows a pattern. And just by doing this, you eliminate an enormous number of pipelines that you would potentially have. And as a developer, if I want to add a service, I basically look at this and think, okay, this is going to do so much work for me. I want to make sure that my service is conformant so I can take advantage of this. So there's an instance of a pipeline in use. Now, the next thing I want to talk about just briefly, and then we're going to start getting into some Q&A, is about deployment. Now, the issue with using microservices is as you have more complex infrastructure, the interaction between those services becomes more complex and more difficult to test. Now, imagine if we had, let's say, 1,000 microservices. Do I want to spin up a copy of 1,000 microservices every single time I make a commit in order to run integration testing? Probably not. It's going to be prohibitively expensive, and also some of those microservices might be external. Maybe I've got like a Salesforce instance. And I'm not spinning up a new sandbox every time I make a change. Or maybe I've got, RDSs or something in there that I need to run against. So as your infrastructure complexity goes up, the usefulness, of testing early starts to go down. And this is where Canary becomes really valuable. And I'm not going to talk super long about this, but basically the idea with Canary is that you release a new version of your application and you only expose a small subset of your users to that new version. And if there are any issues, you automatically roll back. If you want to learn more about that, there's a whole video on it at codefresh.io/events/canary deployment helm Istio Codefresh. You can also just search for it, Codefresh Canary webinar, and you'll find a video on that specific topic. But that's pretty critical when you get into microservices to have that kind of advanced deployment methodology. So in summary, shared pipelines, way better than shared libraries. Also, reusable Docker images, gonna work a lot better than copy paste because people are essentially serving, they're self-serving an artifact and working on it, which is great. And then deployment validation with Canary, very valuable. There's also a companion blog post to this video at our blog. It's just codefresh.io/continuous deployment, CICD pipeline microservices. You can actually just search for the topic. It's on our blog. It goes a little bit deeper than what we went into today, but covers some of this stuff in case you want to look at it again. So that's the quick summary. Now I know we do still have a giveaway, but before we do that, I want to now bring on the line Kostas, who's a DevOps expert, who's an evangelist at Codefresh. He actually is the one who wrote that blog post and actually did a lot of the work that this video is based on, this webinar is based on. It has a long background as a senior DevOps engineer, so and has gone through this whole process a number of times. So with that, let's jump into some of the questions. Kostas, are you on the line?
Yes, thank you, Dan. I see lots of questions, and I want to start with the hot ones. So Rahul says regarding shared libraries that shared libraries can also be versioned, and that Maven does cool job with versioning. First of all, I have to say that I'm a Java developer myself for more than 10 years, and I've worked with Jenkins. And the reality is that Jenkins is a Java application, like the whole platform. And also, if you want to create a plugin, you need to be a Java developer. So even if the case of Jenkins 1, you had to know how to create a Java application. And again, in the case of Jenkins 2, if you want to write a shared library, you need to know Groovy. And not only Groovy, but also the Jenkins API. Now, if you're lucky and you work in a small company where everybody's a Java developer and everybody can create a shared application, maybe you don't see this problem. But a lot of people, work in big companies where Java is one of the solutions. So usually what happens is maybe you have Java in the back end, maybe you have Node in the front end, maybe some Python script somewhere. So not all people know Java. Now, Jenkins has this approach that if you need to write a shared library, you have to be a Java expert. With Docker-based pipelines, because Docker is not tied to any specific programming language, you can write a plugin in any programming language that you want. So maybe I want to write a pipeline plugin in Haskell, maybe in Rust, maybe in C++. And this is a problem with Jenkins if you only have Jenkins. The whole point of going to Docker is to be able to do to bring developers and operators together and have them work together without any restrictions, or you only need to touch Jenkins if you're an expert in Java and nothing else. So I think it's important that it's better to have a solution that is not tied to Java and a specific API. Dan also mentioned this, but maybe it wasn't clear. All the plugins that he was talking about, like the Docker plugins, are just standard Docker images. Even though we use them in CodeFresh, they don't have anything specific to CodeFresh. There is no CodeFresh plugin API that you need to know. It's just a standard Docker image. So if you want to version it, you use the Docker tags. If you want to test it, you use your normal testing. If you want to store them, you use just a standard Docker registry. So everybody knows how to work with Docker images. So I think this is another big advantage. This also brings me to the next question from Anthony, who says, I thought Docker-based pipelines were already best practices, but I guess you guys have added more plugins with Docker in your pipeline. So as I said, yes, we are using Docker images. We have not added anything else. But the important point here is that with CodeFresh, this is the only way that you can create a pipeline. So with Jenkins, you can use Docker, but it's not compulsory. I can still take a Jenkins instance, create a spaghetti of Groovy code or maybe another big script, not use Docker at all, and then have a big pipeline that nobody can maintain, nobody can change, and everybody hates to work with.
Yeah.
And this happened because Jenkins was a solution that existed before containers appeared. So Jenkins kind of adapted into this approach. While with CodeFresh, that's the only possible way. You must create a pipeline with Docker containers. You wanted to say something, Dan?
Yeah, I was just going to add another issue with even version shared libraries is that you still have to deal with dependencies between them. So you might version library 1, but if you don't version library 2 that library 1 relies on, then you can still end up breaking things. And that actually can be difficult to figure out where that is coming from, because you have so many libraries that are interacting with each other. Whereas a Docker image is discretely isolated. It really does operate as a single microservice in the sense that it's doing all of the work that it needs to do by itself. So it's not going to ever rely on another library or another image to do its work. So that's another advantage from that perspective. Let's see, and then Anthony had a follow-up question about the volume. He wanted to know, is that on the CodeFresh side? Is that on the client side? Is it in its own Kubernetes cluster? Yeah, you want to take that one?
Yes, so first of all, the shared volume is automatically set up for you. So as a developer who is working with CodeFresh, you don't need to activate it or set it up. By default, all pipelines have a shared folder, which makes sense, right? Because if you're using Docker containers by themselves run in an isolated manner. So if you want to transfer data from one step to the next, you need some kind of communication. So this volume, if you use the SaaS version of CodeFresh, is automatically managed by CodeFresh. You don't need to do anything. It's on the CodeFresh side. But we also have a hybrid CodeFresh runner where you can still use the CodeFresh web UI, but run the pipelines in your own Kubernetes cluster. So you get the best of both worlds. And then in this case, the volume is on your own infrastructure, but it's fully automated. Like you start the pipeline, the volume is mounted. You copy whatever you want to copy there. So the classic example is, you want to create some test reports. So in one step, you run the tests and collect the JUnit results. And then in the next step, you're using the JUnit results to create the report. So these results are stored in the volume. And then as soon as the pipeline has finished, the volume is unmounted. It will be used in the next build of the same pipeline for caching reasons. So again, let's say you use Maven and you download your dependencies, or maybe Node and you download Node modules. You don't want to download Node modules, every time you run your pipeline. Ideally, you want them to download them once, and then the second time the pipeline is running, the volume is mounted automatically. It already contains the Node volumes from the previous run, so the next build should be much faster. I think this is also related with the next question, which asks about concurrency issues with a common storage volume, and what happens if two containers write the same file on the volume. So the volume is different per pipeline. So if you have multiple pipelines running at the same time, each pipeline is getting its own volume. So this is not a problem. So if you have an application and maybe 4 developers create 4 pull requests at the same time, and then 4 jobs are launched at the same time, each one will get its own volume. So there is nothing that you need to worry about there. You are not going to break the build that is running from another developer. The pipeline volume is reused within the same pipeline if you have parallel steps within a single pipeline. So we're not talking about having parallel pipelines, we're talking about having parallel steps in a single pipeline. Then the volume is reused, and it acts like your normal workspace. So we don't offer any guarantees there. If you have a Docker container that is removing a file on a mounted volume, and then another Docker container is writing this file on the same volume, the end result is undefined. So you need to be careful there when you're going to use parallel steps. But usually you use parallel steps like for, test reports, or maybe building Docker images at the same time. So this is not something that is usually problematic.
Yeah, and something else to add on that. Typically in a step, you can specify like the path within that volume of where you want to push things. So if you want 2 steps concurrently to be writing to the same file, you can do that if you really wanted, but in general, you're not going to be using like a shared log, right? You're going to have a log. You're going logging is just happening anyway in the background aside from the volume. But if you wanted to have push things into a file or something, you're probably going to specify the path for that to be specific to what you want. So those are great questions. And actually, from a concurrency standpoint, this is kind of on you to make sure that you aren't trying to push to the same exact path from 2 different steps when it's concurrent, because they're sitting in a concurrent step. But that volume this kind of goes back to the rules that we talked about earlier. There are a lot of smart rules that you need to have for how you manage a volume that's shared and persistent. And so, as Kostas mentioned, most of these have been, I think these things are pretty well taken care of, at least within the CodeFresh platform. Great question. So next question was, is CodeFresh an alternative for Jenkins or GitLab? The answer is yes. CodeFresh is typically a replacement for Jenkins or GitLab CI. Now, CodeFresh integrates with GitLab version control, GitLab issues, things like that. But for CI, it would be a replacement. And this goes as well for Azure DevOps. CodeFresh is typically a replacement for Azure DevOps, though it's true that you can always integrate, like if you wanted to have CodeFresh just do the continuous deployment step and have a CI happening in another tool, you could certainly do that either with Azure DevOps or Jenkins. Now, if you're talking about Azure DevOps, it's sort of like GitLab, right? Azure DevOps also has version control. CodeFresh does integrate with the version control from Azure DevOps, so that's good questions. This next question comes from somebody who has Jenkins in their name, so I'm a little, hopefully they're not offended. What steps do you generally follow when converting your monolith into microservices? We had a few questions about how to split up microservices. That's not necessarily the topic of this webinar. It really is probably worth addressing on its own. I think that when you start this, and I want to get to Kostas's answer on this as well, when you start this, you'll typically be having a need like, hey, I noticed in this monolithic application, we have this component that's like search that's being used all the time, and it's outsized. It actually needs way more resources. If we put it into a microservice, we could scale it independently of this other service. So even just picking the most highly used API, calls, and then saying, actually, let's try to make these things their own services. That's usually where I would start from at least a prioritization standpoint. What would you say, Kostas?
Yeah, this is a great question, and I think it also goes along with the previous one that says, if you go to microservices, do you use multiple Git repositories or one Git repository? which is, let's say, one of the most important questions. Now, this question actually needs, a whole presentation to answer it. Like, we can talk about 2 or 3 hours. But I can tell you how you should not convert your monolith into microservices. So usually the worst case scenario is that a developer or a team of developers go into the monolith, and then they look at as a technical team, and they start taking things out that they think should become microservices, and they are trying to split things on the technical level. And then once they are finished and they think, okay, now we are done, we have split the monolith, the business comes with several requirements where the technical team thought that they could be like independent, but they find themselves that in order to implement a single change from business, they have to change 10 microservices and redeploy them again at the same time. So now they have a distributed monolith because they didn't gain any of the benefits of microservices. And one of the most important benefits is the ability to deploy something on its own. So in order to do this split, you need either to have worked in your company for, I don't know, like a long time, so that you know not only the product in the technical level, but also in the business level, and have the understanding of which business capabilities can be split into microservices, so that when business request comes to you, you know beforehand, okay, this is a new feature, and I know I need only to change one of my 5 microservices. If you have done this, then you have succeeded. But usually people do it the wrong way, and sometimes, you split something and it doesn't work, and then you ask for a second chance to split things in a different way. So my answer to this question would be, make sure that you split your monolith in the business level and not in the technical level. And sometimes the technical level, it's much easier because you are a technical person, you are a developer, you have all the technical details in front of you, and you think you can split it. And this does not happen. Also, the other question, if you are going to use one Git repository or multiple Git repositories, when you do go to microservices, like there is not, an answer that will work for everybody there. Each company is different. I think it depends on how often the changes come after you do the split. So if you know that some parts maybe are stable, they have not changed in a long time, you are not going to get business requests for this particular thing, maybe you can split it in a separate Git repository, because ideally you would compile it once, have it as a binary or as a library, and then you are not going to touch it. But if you don't know this answer yet, it's best to go with a monorepo where all your services are there, so all developers know that they can check out something and have the whole overview of the whole platform. If you do go this way, make sure that the CICD solution that you are using, and Codefresh has this, has support for monorepos. Because ideally, if you have a single Git repository but you have 5 applications there, if only one changes, you should run like the respective pipeline. You should not launch 5 pipelines just because a single change happened in one of the 5 applications. So Codefresh has this built-in, done so this field in the Git triggers. Other solutions do not have it, and we have seen several people working with Jenkins, writing huge spaghetti scripts with Git diffs, where they're trying to understand if the change that happened actually affects the microservice they are using.
Gets a little hairy. Let's say, I know we just want to be conscious of time. We only have a few minutes left, and we have quite a few questions, so we're going to try to get through a couple of these very quickly. I like somebody asked, is it easy to implement? I'm going to say yes. We'll at least provide some of the materials after this that you can read up on. Another question was about polyglot apps. If we have an application that uses lots of different languages, different microservices, often what I see actually is a different pipeline for each language. I don't know this is necessary if you can do things like abstract using like a Docker file, where it's like my build step is just running a Docker file, then I don't necessarily need to care. It may be relevant when it comes to test suites. That would be my only other comment on that. Then there's a question, can a small business use Codefresh? Yes, we've got lots of 1 or 2 developer shops using Codefresh today. You might even just qualify for the free tier. There was a question about, does CodeFresh keep history of deployments? The answer is yes, and you can actually do one-click rollbacks as well. So that's another value you can do. Another quick question, for deployments, how does CodeFresh bring together code, which is global, with config, which depends on environment, and credentials that depends on environment? Kostas, you want to take that one?
So you have there several capabilities. Actually, I think, again, this is a whole webinar on its own. You can use local configuration, like have the pipeline and all the variables and the data within the same repository where your application lives. You can have your pipelines and configuration in a completely separate repository, and you can even group like things that belong together. So maybe you have one Git repository that only has pipelines and nothing else. Then you have another Git repository that has Docker files and nothing else. So it all comes down to what you want and how you're going to organize stuff. The simplest way to start is to just have a single Git repository where the application plus its Docker files plus its configuration plus its pipeline is there. We also integrate with external solutions. So if you, let's say you want to use secrets and you're using HashiCorp Vault, you can do this. Also, CodeFresh has a set configuration facility on its own for this kind of thing.
Yeah, and I also think that when pairing with something like Helm or Terraform, or even Docker Compose, those things are tied to the repo where the microservice is. And so you can basically take them with context. So if you have the understanding of which one you're using or kind of standardize on that, then you can actually manage the environment configuration in a very straightforward way. When it comes to variables, you can either just make sure that they're available in the pipeline, or like Kostas said, you can have them checked out, essentially being matched with a vault or something like that. There was a question, can CodeFresh handle monorepo? The answer is yes, because there is built-in filtering for all those different elements. Then there was another question that I wanted to get to that was, what's best practice, monorepo or each microservice in its own Git repo? I think this is actually more of a preference thing. I don't know that there is a best practice here. There are certain scenarios where it's better to do one or the other. So I think from my perspective, I want to just support both. But maybe Kostas, you have a stronger opinion about it.
I talked about this before, like if you know that some things are not going to be touched and they are stable, maybe you should convert them so that they have their own Git repositories. But if you don't know this, I would start with a single Git repository that has everything.
Yep. Another question, can CodeFresh integrate with bug tracking systems to create issues based on test results? The answer is yes, because essentially you just need a Docker image that that knows how to push an issue. And so we actually have one for Jira, and I think we have one for ServiceNow and a few other ones. Kostas?
Dan?
Oh.
I'm sorry, this is Charlene cutting in. We're 2 minutes to the top of the hour, so we actually have to stop the question and answer period now, unfortunately. I know you want to, I know if you had all day, you do all the questions, and that is awesome, and I know the audience really appreciates that, but we are up against a time limit, so unfortunately I need to cut you off.
All right.
So real quick, before we close things out, we do have 3 more polls that I do want to push out real quick. And then we'll do them very, very quickly, and then we'll do the Amazon gift card drawing. Here's the first of the 3 final polls. If you could, folks, just let us know what your primary responsibility is. Engineering manager, automation manager, CICD implementation or application engineer, or that ubiquitous other. Just let us know, and then we'll get to the second of the final 3 polls. And then we'll do that gift card drawing and let you guys go. Okay, I'm gonna go ahead and close out this poll, and then we'll push out the next one here. Okay, the next one is about the webinar itself. Did this webinar meet your expectations? It was awesome. It was expected, what you expected, or not exactly. So if you could just let us know about that one real quick, and then we'll move rapidly along to the gift card drawing. We'll give you guys a couple more seconds to to submit your answer, and then we'll get to the final poll. Okay, okay, great. We're going to go ahead and close it out now. Thanks to everybody who did submit their questions. And then the final one is a fun one. Do you want to try CodeFresh? So let's schedule a one-to-one. Yes, I will try it on my own, not right now, or I don't really understand what CodeFresh does. So if you could go ahead and submit your answers for that, and then we'll get to that gift card drawing. So lots of fun today, guys. What great questions we got from the audience, and what a great presentation. So thanks very much. Okay, we're going to go ahead and close out these polls now. And we're not going to share the results. So I do want to real quick, go ahead and do the final, let's see, the Amazon gift card drawing. So our winners are Mark Sosa, Risa Shigemoto, and Kaio Morales. So congratulations to all three of you. And thank you everybody for those who did submit your questions. Good stuff. I'm sure that folks at CodeFresh will be more than happy to follow up with you offline if we didn't get to your questions. Want a quick reminder, today's event has been recorded. So if you didn't hear all of it, or if you just want to watch it again, you have the opportunity to do so. We'll be sending out a link that contains, in an email that contains a link to the webinar on demand. And the webinar is also going to be on the devops.com website, so you can always find it there. I do want to thank the audience for joining me today, as well as Dan and Kostas. So thanks guys, appreciate your time, appreciate your presentation. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.